I like CMRI. That might sound strange coming from someone whose loft is currently in pieces switching from CMRI to MQTT. But even since I made the decision to do that, things have changed with CMRI and it's just become a little bit simpler and easier to use over Ethernet and Wi-Fi. I've used CMRI since I started this layout and I've never known anything else for the kind of accessory control that comes with automation. It's CMRI attached to JMRI that controls or communicates all the changes on sensors, block detectors, turnouts, motors, micro switches on turnouts, and really everything else that's not a train. And it is at a beginner level, it is very, or even at an advanced level, it's very efficient, it's very understandable. And considering that at some point down the Arduino route, you're probably going to have to deal with some code at some point anyway, it's kind of a minimal code thing. The only issue I ever had with CMRI was that I had to use, or felt I had to use, RS485 to communicate the CMRI messages around the loft. I won't go into it again. I've mentioned many times the problems I've had with RS485 that may or may not be my own fault. I'd have always preferred to use Ethernet. I did a number of years of jobs where I worked closely with Ethernet, TCP/IP. I'm fairly adept at putting a network cable together, and I sort of understand it. So I would have much rather worked with it. There were just one or two issues in JMRI that made it just not perfect, a little bit more complicated than it needed to be, and maybe a bit of a no-go. But very recently, in fact, so recently that it's not even in an official release yet, those last few issues appear to have been resolved, which makes working with CMRI over Ethernet or Wi-Fi almost as straightforward as, from a code point of view, as working over USB or RS485. But here I've got, I've mentioned before, a little Ethernet module. I think this is an AZ delivery one, 3 for about £21, W5500, I think. And it's connected to the ICSP header this time on the Arduino Mega. And the SCS pin is plugged into pin number 46 just because it was the closest pin to this little clump of pins here. I'll try and draw up a diagram of how this ICSP header, I've never said that right yet, is configured in terms of pins because they're not actually labelled on the board. Maybe this is a good time to throw in a couple of caveats and disclaimers as well. CMRI, the protocol, is kind of designed to run on RS485, and the implementation of it in JMRI is expecting RS485 communication, really, and it works well over it. So anybody who has CMRI working over an RS485 connection and working reliably would have no reason to switch to Ethernet or Wi-Fi. I don't think. I mean, if I was to get rid of this RS485 and replace it with Wi-Fi, I'm not exactly going full wireless. So again, there's so many wires involved in a layout that maybe removing a couple of them isn't going to make a huge difference. Certainly wouldn't to me. TCP/IP based communication methods like Wi-Fi and Ethernet, certainly if someone is just starting out down this path of getting accessories communicating, then if Wi-Fi and Ethernet is the preference, then look at MQTT, especially if you're natural with code. However, if someone's using CMRI, my experience of it, certainly having now maybe got 90% of the way towards transitioning to MQTT, CMRI requires less code, and the code that's involved in it on the Arduino side is less complicated and easier to maintain in the sense of adding the odd turnout and adding the odd sensor. So certainly someone who's maybe was in a similar predicament that I was in, that couldn't quite get CMRI working over RS485, but was a bit reluctant to switch to anything else, then perhaps the switch of continuing to use CMRI but over Wi-Fi or Ethernet would be a viable option. It's it's maybe worth mentioning at this point as well, especially bearing in mind the caveats and disclaimers, that anybody who's got this far, I'm not assuming that anyone who's new to this whole accessory thing is going to go down this path. Someone who's new to it wants TCP/IP is going to go down the MQTT path. So anyone who's got this far is kind of familiar with CMRI already, familiar with how it works over RS485, connection to JMRI, all that kind of stuff. So I'm just going to kind of dive in and go through the differences in the code to get it working over Ethernet. And with that in mind, I'm planning, what I'm going to do is, there's a very good example. Always look at the examples in the examples folder, which also has very good instructions on how to get connected up as well. And it just does a very basic connection to CMRI, and I think it's like a blink thing that the LED on the Arduino goes on and off according to the state of a light in JMRI. So what I'm going to do is I'm going to adapt this sketch to do pretty much the same thing, maybe include sensors as well, but over Ethernet instead of over RS485. So the first thing you need for Ethernet is a few IP address settings, IP settings. You need a unique MAC address. Again, I'll include a link to it, but there's a great resource here that just generates your random MAC address every time you click refresh. You can copy this line in its entirety and dump it into the sketch. IP address needs to be a unique IP address on your local private subnet network. The easiest way to work out what you're really going to need with that is to get a command prompt up and type ipconfig at the command prompt, and you're looking for the IP version 4 address, which in this case, in my case, is 192.168.100.19. It also tells me what my default gateway is there as well, and my subnet mask, in fact. So what I need to do, I would be, it's likely that on my network, for example, I have an IP router connected to my broadband connection, and it's doling out IP addresses on DHCP. It's likely to hand out ones in the lower numbers here. It's very probably possible to get a DHCP client for these Arduino sketches, but that's kind of beyond this scope. So I've just guessed IP addresses that are high in this 192.168 range. Not too high, don't go above 254. But something up there is unlikely to clash with something that already exists. And I've got my gateway and my subnet mask from there as well. I need a TCP port to work on. This needs, again, the higher the better. I've just gone for the number that was painted on the first train I ever remember being bought as a child. And same as before, a CMRI node address. We then initialize our Ethernet server on the TCP port. The server is going to serve requests effectively from JMRI. JMRI sets itself up with CMRI as a client, so we need to provide it with a server to connect to. So that's what this Ethernet server is. But we're also going to need a client, because JMRI will be the client of this server. So that's what that's setting up here. And this is the bit I really like. CMRI is pretty much just the same instantiation of the class, and exactly just the same library, no modifications. And that's because I'm kind of guessing here a little bit, but Michael Adams, when he wrote the CMRI, maybe he wrote the CMRI library first, maybe then he then added the Auto 485 library. The Auto 485 library handles the RS485 bus, and maybe he needed to be able to pass in that RS485 bus into his CMRI class so that that could communicate with it. And the way he did that, although I'm probably guessing a bit here, because I don't know C++ that well really, I've gone into the wrong library there, is when CMRI instantiates here, when we pass it the serial connection that it's going to use effectively, or it's expecting a serial connection, maybe because again, I'm guessing because I don't know C++, maybe because it might be serial, it might be the Auto 485 bus that is created. It seems like it accepts any class that is a derivative of the stream class, and fortunately the Ethernet client is a derivative of the stream class, so we can just shove that down the pipe and it's perfectly happy with it. It will use the Ethernet client, incredibly, to communicate to CMRI and JMRI just as easily as it will use the serial stream class. So that's really the last of the major modifications that we need to make. Other than these just couple of lines here in the setup void, we've got ether.init and the pin number that the SCS connector is in. If I was using a standard Ethernet shield, something like that, I think that would naturally connect the SCS pin to pin 10 on the Arduino, but because I'm not, all I did was pull the SCS cable and plug it into the nearest pin to that ICSP header, which in this case was pin 46. So if I have that non-standard SCS connection, I need to include this ethernet.init line with the pin number that it's connected to here. Then it's just the standard ethernet.begin, sending the MAC address, IP address, gateway and subnet that we defined earlier, and then a small 250 millisecond delay to let everything settle down before heading really just through some basic config and into the void loop. I've got this wait for JMRI, this little void here that just handles the connection to the it effectively sits and waits. There's no point in this script running, this sketch running on the Arduino, if JMRI isn't running, because it lives to serve and communicate with JMRI. So it just sits and waits for it. This does handle a reconnection as well, so if JMRI is restarted or something, it'll handle that. Just sits and waits for it to connect, accepts it and sets it to this JMRI client, Ethernet client class that's going to be sent into the CMRI library, and just does a little bit of serial output as well. So once it's connected to JMRI, a quick update of sensors, which is just simply setting the data array that CMRI manages, that it sends off in response to polls, and reading digital pin 2 in this example, and which just has a micro switch attached to it. CMRI process, which is the main reading of any data that's coming from CMRI, responding to any polls with the current state of those arrays that we've been updating down there, and then just handling any updates that the process has, any transmits that have come from CMRI, JMRI, handling those and changing the state of any outputs, in this case the digital pin, the digital LED pin that might have come from JMRI. Next then, there's some configuration work that needs to be done in JMRI, and with the new profile loaded, I need to set up the connections, and so I'd still go to CMRI, and this time I would choose network interface, and the IP address host name is the server that I've just created, so that was on 192.168.100.120. I've got a terrible memory. I've still got the code open here. 120, yes, it's the IP address from here, and the port was 9006, was it? 9006, yeah. So in additional settings, that's where I would enter the port, and I've now got configure nodes, and this is where the first real compromise comes in, and again with relation to really the CMRI the CMRI integration in JMRI, really expecting you to use RS485 or serial. So we'll set a node address of 1. Oh, and actually, before I get to it, this is the bit that's kind of been fixed in the recent updates. Polling, I've kind of mentioned before, was the mechanism whereby JMRI would say, right, I need an update on all of the sensors on all of the nodes that I'm connected to. So I'm going to send a request out, and that's what the poll is. It sends a request to every node it's aware of, and the node receives that request and knows by receiving that request that it's its turn to send sensor information back. And that's to do with how RS485 works as well, the half duplex, where the master, which in this case is JMRI, needs to give all of the slaves permission to send sensor updates, and that's what the polling mechanism is. When we're not on RS485, we don't need to have polling. It could be argued that polling is a little bit wasteful of resources now, because we don't need to give anything permission. Anything can talk when it wants to talk. However, removing polling would shift the responsibility of managing the state of sensors to the nodes. So at the minute, you can kind of be a bit ignorant when polling's there. You can just say, right, well, I know that 4 times a second JMRI is going to ask this Arduino for the state of its sensors. So all I need to do is make sure that that array that's managed by CMRI, that's updated in code by doing the CMRI.setBit or setByte commands. I know that that's just going to be sent 4 times a second, so I don't need to know what the current state of a sensor is, what it used to be. As long as I keep that array up to date, then the state of sensors is going to get back. And that's a throwback to RS-485. That's the way RS-485 had to work. It's only a few bytes. It really is only a few bytes, so it's not that wasteful. So if I was to say, well, actually, I don't want polling anymore, I can manage the state of the sensors on the Arduino, then there's more code involved. So I'm going to stick with this polling approach, because that's the minimal code approach, and that's kind of the benefit, really, of using CMRI on TCP/IP over using MQTT. So I'm going to stick with that. So I'm going to add a node. However, this is where a compromise occurs, in that, again, this implementation is designed for RS-485. On a network interface connection here, we have to put each node will have its own IP address, effectively, because each one is an Arduino on a network. However, in this implementation, the IP address is entered at a connection level, which means if we're using a network interface, we have to have an additional connection for every node on the network. So for me, whereas in the RS-485 implementation, I had one connection and it had 3 nodes, if I'm doing an IP implementation, I need 3 connections, each with 1 node. And I would probably recommend having those nodes, although they could all be node 1 on each connection, probably having them with different numbers, just so that they're identifiable. It will work. It just means there'll be a lot of connections across this tab, and it'll just look a little bit messier, but it will work. So I'm going to save this, and it's going to ask me if I want to restart. And just while JMRI is restarting, I'm going to drag this code back on and bring the serial monitor up, because that should give us some useful output as well. And just now select the right profile on Panel Pro, which is off screen, but it's now appeared on screen, which is good. So down here, this is looking promising. We've had a misspelled JMRI connecting. Did I really do that? Is that down in JMRI? No, I didn't. That's strange. But anyway, JMRI connected is now on the debug output, and it's looking good up here because it's connected and not giving me an error message. So the first thing to do on this new profile is to test the I guess lights. So I'm going to add a light just to match up to that onboard LED, and it's expecting it to be on ID 0 in the array, which is 1001 here. So just call it LED, create it. Did I create that? Yes, I did create that. So it's defaulting to off, and hopefully I have to stand up so I can see this, but if I do an on and off, the LED is going on and off on the Arduino, which is the first good sign that this is working okay. Second thing to do is test the sensors. So I will add a sensor, which is put on the screen again already. So I'm going to add a sensor at 1001, which again is that ID 0. Create that, and I think a good start here. It's set to inactive currently, which might be an opposite thing. It might need flipping, but that's easy to do. Inverting, which is easy to do, but yeah, so it does need inverting, but we are getting a reaction here, inactive and inactive, when the sensor is hit. So this is all working over Ethernet. The only thing that's happening over serial is this debug output, and the last thing to check would be the CMRI monitor to make sure, again it's gone off screen, that we're polling and getting responses to polls, which only happens once we have a sensor attached there. So that really is CMRI over Ethernet. It's really not that much additional code to implement over the hello world thing, and moving forward with it, the only thing I would really do is add more sensors in here, more digital reads as I add sensors, and maybe handling of servos, turnouts, that kind of thing. But that really, from previous sketches that I've written, would just be copied and pasted into this one. Now I know that this one is running an Ethernet connection as I'd like it to.
So that's CMRI over Ethernet then. I've tested it quite extensively over the last week or two, and I'm pretty confident that it does work as expected, and that it's easily as efficient and matching in the performance of RS485. One major caveat, I guess, is the release of CMRI that fixes the polling and makes this whole thing work is yet to be released. I was using a kind of test debug release in the video, so the devs have signed off the work, and it's due to be in the next test release, which will probably be 5.3.6. At the minute, the two major releases, the major release is 5.2, which doesn't include it, and the latest test release is 5.3.5, which doesn't have the fixes in. But the fixes are signed off, so they will be included in the next releases of both of those strands, those branches of work. Having got Ethernet working, my thought did immediately move to Wi-Fi and to get the thing working without Ethernet cables altogether. And initially I thought that would be quite a straightforward process because it's still TCP/IP and I've got most of the stuff done. I was, however, quite surprised. There are a few hurdles and there are a few different approaches that need to be taken to get CMRI working comfortably over Wi-Fi. It's quite in-depth. It's perfectly doable. It's just a little bit more in-depth. So I will put all of that in a separate video, as it might probably go on a little bit longer than this one has.